why does this phenomenon occur? The phenomenon of optical activity occurs in enantiomeric compounds because of their chiral carbons, which gives them a unique three-dimensional structure that causes them to interact with polarized light in different ways. Specifically, if you have a chiral compound in an R versus an S configuration, it'll twist either left or right depending on the conformation of the molecule because of this unique three-dimensional structure. Why do the various compounds alter the results? What causes the differences? Different compounds bend light differently because they're different molecules. They contain different molecules that contribute to a varying molecular weight, varying molecular size. They might also contain molecules that behave differently with light. From what I understood from my own research, it's to do with how they interact with electrons in these molecules. So obviously, all molecules contain different electron clouds and whatnot. So the way that those are configured will change the way that the angle of rotation behaves with a certain compound. So this gives them all their unique specific rotation. How do you know these molecules are all optically active if they are? So first and foremost, we know that they're optically active if there's an observed rotation of light. So we saw some degree of observed rotation in all of our examples, some more than others. My dextrose was not super great, but we know this because all of these molecules have chiral centers, and because we saw an observed rotation of light, we can assume that they're not perfectly racemic mixtures. Racemic meaning that there's different amounts of R and S, and if it's a perfectly 50-50 racemic mixture, then all of the R and all of the S, because they bend light to the same degree in opposite directions, it'll cancel the light out completely. How does the concentration, purity, and identity of the substance affect the results? If a solution is more concentrated, then that means that there's more of the chiral carbon molecules in the solution, which will be more available to interact with more light, so you will get more of a degree of rotation measurement. So if it's not completely, if your concentration is off, then you will likely have an inaccurate rotational angle that you measure. Same thing that if it's impure, you might have other chiral compounds in the solution that skew your measured angle of rotation. And since the angle of rotation is specific to the identity of the molecule, it's important to have pure solutions or correct concentrations of solutions. What must occur for the phenomenon to be observed? As mentioned previously, molecules or compounds that are chiral will have optical activity, and enantiomeric will have optical activity. So we talked in lecture a lot about meso compounds are not optically active, and that's because they are the same molecule depending on the way that they're oriented and viewed. And then also for the phenomenon to be observed, we have to use polarized light due to the way that it's arranged, and it's not just sporadic all over the place light. It's filtered to be a certain way so that it gets bent a certain way.